All right, good morning, good evening, good afternoon, folks. Let's go ahead and we're going to be multiplying sum and difference of two terms. All right, so check this out right here. All right, let me just multiply this using the regular FOIL method, and then we're going to see something happen here, and then we'll get to our cool little thing right here. Okay, so if I were to use FOIL and do my first inner, outer, last, that would be m squared, right? And then m times negative 5 is a negative 5m. And then 5 times m is a positive 5m, and a 5 times negative 5 is a negative 25. We can combine our middle terms, and actually that's a negative 5m plus 5m. That just cancels out to 0. So we're left with just m squared minus 25. Okay? Let me do that again over here. X times x is x squared. And I'm just doing these quickly, and then I'm going to backtrack, and then we'll get to this up here. And then x times 4y is a positive 4xy. And then negative 4y times x is a negative 4xy. Negative 4y times 4y is a positive 16y squared. Okay, let me just kind of move that over a little bit. Okay, and then we combine those together and get 0. So I have left x squared plus 16y squared. Okay, I want to stop right there real quick. I just want us to do some noticing real quick. What do you notice about what happened in problem A and B? There's something that happened. And as you can see here in this second line right here, see how those canceled out and those canceled out. Okay, and the middle terms will always cancel out if the problem is written as a term minus a term and then a term plus a term, where these two terms, okay, right here, see right there, that those are exactly going to be the same, and these two terms are exactly going to be the same. So the first terms are always the same, and the last terms are always the same. And the only thing different is one is a minus and one's a plus. That's the only thing different. Same thing right here. Look, same term, same term, 5 and 5. And the only thing that's different between is that one's positive and then one's minus. When we see that happens, okay, we know that the middle terms are always going to cancel out. They always see the negative 5m and 5m canceled, and the 4xy and negative 4xy canceled. But also, if you notice here, if you take our m, if you squared it, then that's what our answer is. And if you take your second term and square it, we get 25. Here you take x, square it, and if I take 4y and I square it, I get 16y squared. So there's this pattern here that happens when two binomials are written like this. And now we get to our formula. When the first two terms of two binomials are exactly the same, x and x, and the last terms are exactly the same, x and y, and the only thing that's different now is one's plus and one's minus. The way that the shortcut now, without having to do all this stuff here, is you take your first term x, look, square it. You take your second term y and you square it, and then you put a minus sign. And so that's why this is called difference of two squares. Okay, the difference right here is the product of the sum and difference of two squares, because what's happening is we are canceling out that middle term, which is only leaving now the first and the last term squared. Okay, so that's how we can get these answers a lot quicker now, as you could have just said, oh look, I noticed that it's x plus y, x minus y. It looks just like this. So I take my first term, I square it. I take my second term, I square it, and I put a minus sign. So here, let's apply that right now. See, if I look at just this right here is a difference of two squares. Okay? And so I take my first term, I square it. I take my second term and I square it. And I put a minus sign. And there you go. If I were to multiply this all out using FOIL, I would get y squared minus 49. Bam! But now I have to bring this down right here, 4y squared. And then now I'm just going to have to use the distributive property to get that bad boy. So 4y squared times y squared it's going to give me a 4y to the power of 4, and then 4y squared times a negative 49. Let's see, that will give us a negative, not negative, yeah, a negative 196. Oh, it changed colors. Y squared. Okay, and that would be it.